Hello, Precalculus students. This will be part 2 to the Rutgers University Precalculus Final Review. Again, these questions were created by the Math Department at Rutgers University. So let's begin with question 11. Find the values of the trigonometric function of theta if the terminal side of theta contains the point -4, 5. So let's sketch that out quick. -4, 5 would be in the second quadrant. So we have -4, 5, show that point, and we're going to make a right triangle and show the reference angle. That is the positive acute angle between the terminal ray and the x-axis. We will call this theta. So this length here would be 4, this length here would be 5. So since we're finding the values of all the trig functions, we're going to need our hypotenuse. We'll solve for that quickly. 5 squared plus 4 squared equals x squared. Take the square root of both sides. 25 plus 16 is 41. So we have x equals the square root of 41. So we have sine theta, cosine theta, tangent theta, and their reciprocal functions. So cosecant theta, secant theta, and cotangent theta. So sine is opposite over hypotenuse. So 5 over radical 41. Remember, all students take calculus. So in this quadrant, only sine and cosecant will be positive. So sine is positive. If you want to radicalize your numerator, you can. So multiply by radical 41 over radical 41. That's 5 radical 41 over 41. Now for cosecant of theta, that would be adjacent 4 over hypotenuse, square root of 41. If you want to radicalize your numerator, we would have 4 radical 41 over 41. And then, because it's all students take calculus, it would have to be negative. Tangent is opposite over adjacent, so that would be 5 over 4. And then because it's in the second quadrant, it's negative. Now cosecant is the reciprocal of sine. So remember what sine was before we radicalized the numerator? We could just do the reciprocal of that. That way we don't have a radical in our denominator, and then we have to radicalize the numerator. So then for cosine, it would be negative square root of 41 over 4. And then for cotangent, it would be negative 4 over 5. Right? Okay. Question 12. It says, find cosine of the double angle given cosine of x equals -4. So your double angle formula for cosine is cosine of 2x, let's say, equals cosine squared x minus sine squared x. We have what cosine equals. We don't have what sine equals. So to find that, we could use our Pythagorean identity. Sine squared plus cosine squared equals 1. So cosine is -4 over 5. we can subtract the negative 4 over 5 squared, which is just positive 16 over 25. This cancels out. We get sine squared theta equals 9 over 25. Take the square root of both sides. You get sine of theta equals 3 over 5. Now it's in quadrant 2, so sine is positive, so we leave it as positive. And now it's a matter of just plugging in. So cosine is negative 4 over 5. That was given to us. We're going to do squared minus sine is what we solve for. 3 over 5 squared. So then that is 16 over 25 minus 9 over 25, which is 7 over 25. Okay? For question B, you're going to do your double angle formula for this. So use your Pythagorean identity to find cosine. So sine squared plus cosine squared equals 1. We could subtract this. This is 4 over 25. So now we have cosine squared of x equals 21 over 25. Take the square root of both sides. Cosine equals square root of 21 over 5. And now that we have cosine, because it's in quadrant 2, you would make cosine negative. So now that we have cosine and sine, we just plug into our double angle formula, right? The cosine double angle. Oh, we're sine. Your sine double angle formula is sine of your double angle equals 2 sine x cosine x. So we have 2 times 2 over 5 times negative radical 21 over 5. That would be negative 4 radical 21 over 25. So that would be your answer to B. Alright, and now lastly, for C, I'll erase all this so we have room. We have our sum and difference. So this is the sine, sum and difference identity. So first sine maintains the same sign, so it's a plus sign, so it's plus. And with sine, you have alternating trig functions, sine and cosine. Okay. So you're given sine of x is in quadrant 3, and you're given sine of y. So we're going to have to find the individual cosine x and cosine y. So I would recommend still using the Pythagorean identity. So negative 2/3 squared plus cosine squared of x equals 1. Subtract your 4 over 9 on both sides. So we have cosine squared of x equals 5 over 9. Take the square root of both sides, and you would get cosine of x equals square root of 5 over 3. Because it's in quadrant 3, remember all students take, it would be negative. Because only tangent or cotangent would be positive in quadrant 3. Now for sine of y. we have 1/3 squared for sine squared of y plus cosine squared of y equals 1. And we're going to do the same thing. Subtract 1 over 9. We have cosine squared of y equals 8 over 9. Take the square root of both sides, and we have cosine of y equals the square root of 8 over 3. If you wanted to simplify, the square root of 8 is 2 radical 2, but maybe let's hold off on that because we might want to combine your denominators. We'll check it out in a little bit. So, let me highlight all my cosines. This is cosine of y, and also, what was that? That was quadrant 2. So, because it's quadrant 2, all students, so it should be negative. So that's your cosine of y, this is your cosine of x, this is sine of x, and this is sine of y. So sine of x, negative 2/3, cosine of y, negative radical 8 over 3, plus sine of y is 1/3, cosine of x is negative radical 5 over 3. So now I have positive 2 radical 8 over 9 plus negative radical 5 over 9. So we have 2 radical 8 minus radical 5 over 9. And then this is where I would probably convert. So we have 2 radical 4 times radical 2, because you could separate roots by multiplication. Then this is just 2, so 2 times 2 is 4. So we have 4 radical 2 minus radical 5 over 9. Okay, so that's question 12. We did A, B, and C. Okay. Now we want to verify the identities below. So I would always recommend following left and right. So 1 minus sine squared of x over cotangent squared of x is the same as saying cosine squared of x over sine squared of x equals sine squared of x. Now you're dividing fractions. So you're going to do keep, change, flip. So 1 minus sine squared of x times sine squared of x over cosine squared of x equals sine squared of x. Put parentheses around this. So now I have 1 minus sine squared of x. Immediately, when I see 1 and sine squared or cosine squared, I think to myself, that kind of looks like the Pythagorean identity. So let me write the identity. Sine squared plus cosine squared equals 1. So let's see how I could make it 1 minus sine squared. Oh, look at that. I could just subtract sine squared of x. So now I have cosine squared x equals 1 minus sine squared of x. I'm just going to substitute in cosine squared for 1 minus sine squared. So cosine squared of x times sine squared of x over cosine squared of x equals sine squared of x. The cosine squared cancels out, and we just proved that sine squared of x equals sine squared of x. Right? So that would be your proof or your verification of the identity for the first one. For B, we have cosine of x over 1 plus sine x plus cosine of x over 1 minus sine x equals 2 secant x. So what is secant? Secant is 1 over cosine. So we have 2 over cosine. Now, I see 1 minus sine x, 1 plus sine x. Those are conjugates. So you might want to multiply by the conjugate. So, I'm going to multiply by 1, but by their conjugates. Alright. So now, this is going to be, because when you multiply by a conjugate, it's a difference of perfect square. So I have 1 minus sine x cosine x plus cosine x times 1 plus sine x over 1 minus sine squared, because it's the difference of perfect square. It's just multiplying out. Something that we just talked about, if you have 1 minus, you have 1 and you have sine squared or cosine squared, that looks a lot like your Pythagorean identity. So, to get this to look like that, I would subtract sine squared of x on both sides, and we know that it equals cosine. So, I'm going to do two things in one step. I'm going to replace this with cosine squared of x, and I'm going to factor out the cosine of x. So, I have cosine of x times 1 minus sine x plus 1 plus sine x over cosine squared of x equals 2 over cosine x. This cosine cancels out and 1 cosine cancels out here. And now I would probably just add these. So 1 plus 1 is 2. Negative sine x plus sine x cancels out over cosine x equals 2 over cosine x. If you wanted to get it to say 2 secant x, this is just 2 over times 1 over cosine, which is 2 secant. So 2 secant x equals 2 secant x. Okay, we proved it. Both sides are identities. Alright, question 14. Find the exact value of the inverse of sine or arcsine of negative 1/2. So I know my inverse trig functions solve for the angle. So I'm going to say equals theta. And then, if you wanted to rewrite this, because we're used to that SOHCAHTOA form, you could show the inverse. You could show the original sine of theta equals negative 1/2. So I have to think to myself, when does sine equal negative 1/2? Well, we know that on a unit circle, sine is the second set of values, the y values, right? So it goes 3, 2, 1, 1, 2, 3. So we said the 1 first, right? So that is for pi over 6. So it will go 3, 2, 1, 1, 2, 3. They're all over 2, all with the square root on top. So that is where sine is positive. We want negative. So it would also be positive in quadrant 2, right? If we want it to be negative, it's going to have to be in quadrant 3 or quadrant 4. So the reference angle is pi over 6, and we're going to have negative radical 3 over 2, negative 1/2. Could also be in quadrant 4, potentially, and that would be where your cosine's positive, but your sine is negative. So we are going to consider where this reference angle is pi over 6 and where this reference angle is pi over 6. So that's pi plus pi over 6, which is 6 pi over 6 plus pi over 6, which is 7 pi over 6. This would be 2 pi minus pi over 6, which is 12 pi over 6, which is 11 pi over 6. So this is, we said, 7 pi over 6, and this is 11 pi over 6. So those are two potential solutions. Now we have to think to ourselves, what is the domain and range of arc sine? Okay. So for arc sine, the domain is -1 to 1, and the range is negative pi over 2 to pi over 2. So that's going to be from here to here. So the only solution should be 11 pi over 2. Oh, it says find the exact value in degrees. Okay. (11 pi over 6 times 180 over pi. We'll do the next part in only degrees. Pi cancels out. It's 330 degrees. Okay. So your answer could be 330 degrees. Let me just check what your calculator would give you. Or your answer is -30. Because if you think about it, 330 is right here. That would be the positive angle. Or you could go to the negative rotation, right? Which is -30. So theta equals -30. I see. This is so because your range. This question's a bit messy for me. So because your range is negative pi over 2 to pi over 2, that is negative 90 degrees to 90 degrees. So really it should fall in that range. So you have to say -30 degrees. Okay? Well, it'll be much smoother for this next part. Okay? So, for the inverse of cosine, if you wanted to rewrite this, you know that the inverse trig function equals your angle, theta. So if you wanted to write this not as the inverse, you would say cosine of theta equals negative radical 3 over 2. So what we're saying is, what angle gives you negative radical 3 over 2? For cosine. So on your unit circle, remember it's 3, 2, 1. For cosine, that's your x values. So that's the first number I said, the 3. So that's going to be reference angle, and we said we're going to work in degrees. 30 degrees. But this is where cosine's positive. So we have to consider quadrant 2, and we have to consider quadrant 3. Not quadrant 4, because quadrant 4 is also where cosine is positive. So we have to consider 180 minus 30, because this is 180 right here, which is 150 degrees. And we could consider 180 plus 30, which is 210 degrees. Now for the inverse of cosine, your domain is -1 to 1. Your range is 0 to pi. So the range would be 0 degrees to 180. So which of these is in 0 to 180? 150. I would recommend just verifying that in your calculator. Do the inverse of cosine, negative radical 3 divided by 2, and you get 150. Okay, much smoother than the first part of this. So, question 15. Now we're doing function compositions. So you're going to do, and there's no calculator sign on the question, correct? I don't believe so. So let's do your inside to your outside. So cosine, the inverse of cosine of 2/3, that's essentially saying cosine of theta equals 2/3 and now we want to find the angle for cosine of theta equals 2/3. This isn't a calculator question. So this is your adjacent over hypotenuse. Well, you use your inverse trig function to find the angle. Let me make sure this isn't a calculator question. Question 14. It's not a calculator question, so. Adjacent is 2, hypotenuse is 3. Oh, I see why. Okay. So, you could just solve for the opposite. Yeah. So, we have 2 squared plus x squared equals 3 squared. We're going to subtract 2 squared, take the square root. X equals 9 minus 4 is 5, square root of 5. So then, for this same theta, right, you're finding sine. So sine is sine of theta equals opposite, so radical 5 over hypotenuse. So you'd get radical 5 over 3. Okay. The reason that gave me pause is technically you probably would need to use your calculator to find this angle. Or, I mean, you could leave it like this, I guess, even though it's not really going to tell you a value. But it gives you the angle, and then it's going to be sine of that angle. So I was thinking of it as just this part of the question. We're doing sine of that angle. So it's just going to be opposite over hypotenuse. Okay? We'll do the same thing for B. So we have tangent inverse of -6 equals theta. So then tangent of theta equals -6, or -6 over 1, right? So that's going to be your opposite over adjacent. So let's say I had this angle theta, opposite is here, adjacent is here. We're going to solve for the hypotenuse. So 1 squared plus 6 squared, or I guess I'll say -6 squared, even though it's going to make a positive anyway, equals x squared. Take the square root of both sides. 1 plus 36 is 37. So you get the square root of 37. So then, this gives you the missing sides, even though this means to give you theta, right? And then, you're finding sine of that. So that's going to be opposite over hypotenuse. So, we have, our answer would be -6 over the square root of 37. Okay. All right. For question 16, if theta equals arcsine of x, express in tangent theta in terms of x. So, what that's telling you is sine of x, so not the inverse of sine, as shown, sine of theta equals x. So then, tangent of theta equals sine of theta over cosine of theta. So if we're writing it in terms of x, tangent of theta equals x over cosine of theta. That's one thing you could do. Another thing you could do, you can use your right triangles. So we're saying sine theta equals x. So then opposite is x, hypotenuse is 1. X squared plus b squared equals 1 squared. You could subtract x squared. take the square root, and we get b equals the square root of 1 minus x squared. So 1 minus x squared. And then tangent is your opposite over your adjacent. So your opposite is x. Your adjacent is square root of 1 minus x squared. And this is probably more in terms of x, like how they would probably prefer it. So what we wrote before wasn't incorrect. It's just now there's only data around the tangent. And even from where we were, you could have converted cosine to, opposite adjacent over your hypotenuse, so square root of 1 minus x squared, and then we could have ended up getting the same proportion. Okay. Question 17, and this is a calculator active question. Suppose on January 1st, 1997, Dave invested $2,000 into a bank account at 5% interest, compounded continuously. Let y of t be the value of Dave's investment after t years. Give an exact formula for y of t. So for part A, we know the continuous compound interest formula is A equals P times E to the RT. So it's going to be y of t, because that's your amount, equals P, the initial amount, 2,000, times E to the 0.05 t. That is your formula. So now for B, it says also on January 1st, 1997, John decides to invest. He puts 2,500 into an account at 3% interest compounded monthly. So that is a different formula now. That is A equals P times 1 plus R over N to the NT. That's your compound interest formula, not your continuous compound interest formula. So we have G of T equals your initial amount 2,500 times 1 plus your rate is 0.03 over compounded monthly is 12 to the 12t. If you wanted to simplify, you can simplify what is inside your parentheses. That is 1.0025. Okay, so this is your answer to G of t. Which account is worth more after 9 years? Must show work to receive credit. So, something you could do if you didn't have to show work, you could have put them both into y equals, and then went to where x equals 9, or t equals 9. But you don't have to do that in your calculator. You could do y of 9 equals 2,000 times e to the 0.05 times 9. G of 9 equals 2,500 times 1.0025 to the 12 times 9. And now I'll put this in my calculator. So 2,000 times e, remember e is second divide, to the 0.05 times 9 is 3,136 point, it's money, so we're going to round to the nearest hundredth, 62. And for G of t, we'll do the same thing, 2,500 times 1.0025 to the 12 times 9, 3,273.81. So, which account is worth more after 9 years? it looks like after 9 years, the one that is compounded monthly is worth more. Now we know the more compounding, the better. So with time, eventually the continuous compound interest will exceed the monthly compound interest, but it wasn't given enough time to. So I would write after 9 years, g of t is greater than y of t. To the nearest tenth, at what time t are both accounts the same? For that, what you're going to do is just put them in your calculator. You're going to go to y equals, you're going to type in 2000 times e to the 0.05 x. For y of 2, y sub 2, you're going to plug in 2500 times 1.0025 to the 12t, or 12x. I'm going to graph both of those. I don't see anything on my graph, so I'm going to go to zoom fit. I see them approaching each other, but I don't see the point of intersection yet, so I'm going to go to zoom out, scroll to the right side of the screen where it is, press enter. And now I finally see where they intersect. So I'm going to press second, trace, intersect, scroll over to the intersection point, press enter, enter, enter. And it says at what time, so that's x or t equals, I'll say is approximately because it's at the nearest tenth, 11.1. Okay. So that was question 17. Evaluate the following exactly. Notice there's no calculator, so we're going to have to find a common base. So it's probably going to be base 2, right? Log base 2 of the 7th root of 2 to the, let's say, it goes 2 to the second power is 4, third power 8, fourth power would be 16, fifth power would be 32, sixth power would be 64. Yes. So then we know the 7th root is a 1/7 exponent, right? Because we know, let me write, let's say x to the m over n equals the nth root of x to the m. The denominator is the degree of the root, and the numerator is the power that's shown. So we have log base 2 of 2 to the 6 over 7. And now the exponent on this 2 is 1. The exponent here is 6 over 7. So your answer is going to be 6 over 7 divided by 1, which is 6 over 7. Same for this one. Let's do log base 3 of the 7th root of 3, let's to the something, right? 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. 3 to the fourth power would be 81. So this would convert to 3 to the 4 over 7. And your answer would be 4 over 7. Okay. Now for this next question. Evaluate two decimal places. it really depends on the calculator that you have. You can, on the 2i84s, you could go to math. I believe not. Let's see. Math. Yeah, just go to math, log base, and then you just type in the log exactly as you see. And you end up getting 2.047818583 to the nearest 2 decimal points, so 2.05. Another thing that you could have done on any calculator, even a scientific, you could have done log of your argument, so 27, divided by log of your base, 5, and you would have gotten the same answer. So let's do that here. Let's do log of 15 divided by log of 3, because log of your argument over log of your base. And you end up getting approximately 2.46. All right, that's question 19. Question 20. Find the inverse of these functions. Now, the first step to any inverse equation, you're going to switch your x and y. So I'm just going to define f of x as y. That way I could just replace it. And now, this is still my original function. I'm going to switch my x and y. Now this is no longer the original function. This is my inverse. So I'm going to try to solve for y the way you solve for an exponent. You use logs. So log base argument equals exponent. This would be my inverse. I would then switch that y that we solved for to the inverse of f of x. Okay? Same thing here. We have y equals log base 3 of x. We're going to switch our x and y. And then the way we solve, convert to an exponential. The base is 3, the exponent is x, and the argument is y. And then replace that y with the inverse of f of x. That way you're showing it's the inverse. No longer equals that original function. Okay? I'm going to erase this and we'll go to question part C. For part C, we have, and I'll just switch the x and the y to begin with. So we have x equals 10 to the y plus 1 minus 3. That would, in order to use a log, you have to isolate the base. So we have log base 10 of your argument is x plus 3 equals the exponent y plus 1. You could then subtract 1 on both sides. Remember, if it's base 10, you don't have to write the base. That's your common log. So we have the inverse of f of x equals log of x plus 3 minus 1. Alright, that was question C. Question D. We have, and again, I'll switch the x and the y right to begin with, log of y minus 4 plus 5. We switched the x and the y already, so we're looking at the inverse. We want to solve for y. So, remember, if it's the common log, it's base 10. So it's, and you also have to isolate the log first. Subtract your 5. Now we have base argument, so it's on the other side of the equal sign, equals the exponent, x minus 5. You're then going to add 4 to both sides, and we get the inverse of f of x equals 10 to the x minus 5 plus 4. Okay. That was question D. Now for question E. We have to switch the x and the y still. So x equals e to the 2y plus 1 minus 4. You have to isolate the base first in order to use log. Now you have log base e of x plus 4 equals the exponent 2y plus 1. You would subtract 1 and then divide by 2. So now I have the inverse of f of x. Remember, log base e is your natural logarithm. So you could say ln equals ln of x plus 4 minus, we have 1/2 and 1/2. Okay. So that was e. And now lastly, for f, switch your x and y's. And you're going to isolate the log. The base is e. The argument is 2y plus 3. The exponent is x plus 5. You're going to subtract 3 and divide by 2. So we get the inverse of f of x equals 1/2 e to the x plus 5 minus 3/2. All right. Now for question 21. It says to sketch a graph of the following. Label the asymptotes, find the intercepts, exact, find the inverse, find the intercepts accurate to 2 decimal places. So label the asymptotes that we could just see. The asymptotes, this is a exponential because there's a variable in the exponent. So for f of x, there is a horizontal asymptote. Exponentials have a horizontal asymptote. Logarithms have a vertical asymptote of y equals -3. Find the intercepts. So if it's approaching -3 and it has base e is approximately 2.72, that means that it's exponentially growing. So growing from -3, that's going to definitely hit 0. So we have an x-intercept. So an x-intercept is where y equals 0. So 0 equals e to the x plus 2 minus 3. Add 3. So 3 equals e to the x plus 2. I'm going to do logs. So log base e of your argument 3 equals x plus 2 subtract 2. That's the same as saying x equals ln of 3 minus 2. Find the intercepts exact. So this is the exact answer. Or if you wanted to show the intercepts accurate to 2 decimal places, that's going to be negative 0.9013877113, which is approximately negative 0.90. Okay, now for the y-intercept. A y-intercept is where x equals 0. So we have e to the 0 plus 2 minus 3. That would be e to the 2 minus 3. That's your exact value. But if you wanted to show it accurate to do 2 decimal places, put that in your calculator. And we end up getting 4.39. So let's think about what an x-intercept is, right? An x-intercept, this point, is where y equals 0. So this point is negative 0.90, 0. Same thing for this y-intercept. That is where x equals 0. So it's 0, 4.39. Now, we are still going to find the inverse. But think about what an inverse is. You're switching x and y. That's why it reflects over the line y equals x. So this is going to switch to be 0, negative 0.90 on the inverse. And this is going to switch to be 4.390 on the inverse. So this is going to be your x-intercept. For the inverse, this will be your y-intercept for the inverse. And now, for the asymptotes, remember, you're just switching x and y, so this is going to be x equals negative 3, because now it's a vertical asymptote. And to find the equation, find the intercepts. Did it say, yeah, find the equation of the inverse. You can switch your x and y. X equals e to the y plus 2 minus 3. Isolate the base. And we would have log base e of x plus 3 equals y plus 2. And then subtract 2. So f inverse of x equals ln, because it's log base e, of x plus 3 minus 2. It also states to graph these, to sketch a graph of the following. So, I could group this and I'll make it much smaller. So we still have the information. So for the sketch, the log's going left 3. So first, it started as an exponential, right? It started as an exponential with a horizontal asymptote of y equals negative 3. Okay? So it has a base of e, which is about 2.72, which means it's exponentially growing. We said that the x-intercept was negative 0.9. So let's say that this is negative 0.9. We said that the y-intercept is about 4.39. And again, this is just a rough sketch. So it'll look like this. That is f of x, your exponential. Now for the inverse function. The inverse function, we said that the vertical asymptote would be negative 3. So 1, 2, 3. So the vertical asymptote is at x equals negative 3. And we said that the x-intercept is going to be 4.39. We said that the y-intercept will be negative 0.90. And what that will look like will be like this. So remember, to find the inverse, you switched x and y, right? So all an inverse function is a reflection over the linear function or the line y equals x, because you're switching your x and y. So y becomes x becomes y, right? So this is your inverse. The inverse of a log is an exponential. The inverse of an exponential is a log. Okay. For B, I will leave B for practice. In the next video, we'll be doing 22 to 30. Thank you.